Texas's Ocean Tower, this 31-story luxury skyscraper on South Padre Island, the one that was supposed to be the crown jewel of the Gulf Coast real estate boom, the one with 147 ultra-luxury condominiums, pools, a spa, and panoramic ocean views, the one buyers were lining up to put deposits on before construction was even finished. That entire building had to be demolished before a single resident ever moved in. The columns started cracking in 2008. The central core had sunk more than 14 inches into the ground in uneven settlement. The tower had begun leaning slightly north as the foundation gave way underneath it. And on a single December morning in 2009, a demolition crew detonated 55,000 tons of hurricane-hardened concrete and dropped the most expensive failed skyscraper in Texas history into its own footprint in 12.5 seconds. So how does a $200 million luxury tower built to survive hurricanes get defeated by a layer of clay 120 feet below the surface that nobody bothered to test for? But first, let's go back to when this building was supposed to be the future. This is Ocean Tower, 31 stories, somewhere between 375 and 450 feet tall. Located on South Padre Island, the narrow barrier island that runs along the southern tip of Texas, banking on the open Gulf of Mexico. When construction started in 2006, it was supposed to be the tallest residential structure on the entire Texas Gulf Coast. The project that would finally put South Padre Island on the map alongside Miami Beach and Galveston as a destination for ultra-luxury coastal living. The developer was a consortium betting on what looked like an unstoppable trend. The mid-2000s coastal real estate boom in Texas was at its peak. Developers were racing to plant luxury high-rises along South Padre Island, banking on the idea that wealthy buyers would pay a premium for Gulf Coast views and hurricane-resistant construction. Ocean Tower was supposed to be the crown jewel of that wave. 147 luxury condominium units, pools, a spa, a gym, a media room. The kind of building that looked spectacular in a glossy sales brochure and promised buyers a lifetime of beachfront luxury. The marketing worked. Buyers responded the way developers dream of. Deposits were placed before the steel was fully topped out. People who had spent their lives building toward retirement were signing contracts on units they planned to move into. Investors saw the project as a guaranteed return on the next great Gulf Coast destination. By 2008, the main structure had been topped out and partially clad. The exterior was going up. The interior fit-out was beginning. The developers were already selling the lifestyle. Hurricane-proof luxury, living on one of the most desirable stretches of Gulf Coast waterfront. From the beach, the tower looked like the future of South Padre Island. From the boardroom, the pitch was perfect. But the future had a problem. The problem was sitting roughly 120 feet below the surface in a layer of soil that nobody on the project had fully investigated. And the moment that layer started to compress, every dollar above it was at risk. To understand what went wrong, you have to understand what South Padre Island actually is. It is not solid ground. It is a low, narrow barrier island composed mostly of sand sitting on top of deeper layers of soft, compressible clay. Barrier islands along the Gulf Coast are geologically young and inherently unstable. They shift. They erode. And the material underneath them varies dramatically depending on how deep you look. For a single-family beach house, that complexity does not matter much. Light loads spread across a wide footprint do not stress the deep soil profile in any meaningful way. For a 31-story concrete tower concentrating tens of thousands of tons onto a relatively small footprint, it matters enormously. The deeper you go, the more surprises the subsurface can hold. And the engineers on Ocean Tower stopped looking before they reached the layer that mattered most. The geotechnical consultant on the project was a firm called Rabba Kistner. Their job was critical: drill exploratory borings into the subsurface, characterize the soil profile, recommend a foundation system that could safely carry tens of thousands of tons of reinforced concrete. Their borings went down about 100 feet. For what they found in those first 100 feet, the recommendation seemed reasonable enough. The design called for approximately 401 auger-cast pressure-grouted piles, each about 16 inches in diameter, driven roughly 95 feet deep into a sand layer that appeared stable and capable of supporting the load. The problem was what they stopped just short of finding. Sitting between roughly 120 and 190 feet below grade was a stratum of expandable compressible clay. This was not some obscure geological surprise. Compressible clay layers are a known feature of barrier island geology along the Gulf Coast. Engineers who work this coastline know to look for them. And this type of clay behaves in a very specific, very predictable way when you stack heavy concentrated loads on top of it. It compresses slowly, unevenly, with consequences that compound over time. The piles were bearing in the sand layer above the clay. So the full weight of a 31-story concrete tower was being transferred down through 95 feet of pile into sand, and then focused directly onto a compressible stratum that the geotechnical investigation had not characterized. A foundation designed to go deep, but not deep enough. The borings stopped 20 feet short of the layer that would eventually decide the fate of the entire building. That gap between what was tested and what actually mattered defined everything that came next. Through 2006 and 2007, Ocean Tower rose steadily over the South Padre Island coastline. Floor after floor of reinforced concrete went up. The attached parking garage took shape alongside it. Workers began installing the exterior cladding, while the developers continued marketing units and buyers continued signing contracts. From every visible angle, the project was on track. Then, in early 2008, something changed. Cracks began appearing in the main supporting columns. Not the superficial hairline cracks you would expect during normal concrete curing. Structural cracks, the kind that make engineers stop what they are doing and pick up the phone immediately. Similar distress showed up in the adjacent parking garage, with cracks running through beams and load-bearing walls. The construction site went from production mode to emergency mode in a matter of days. Construction was halted in May 2008 when survey crews came in to measure what was actually happening beneath the building. The numbers they brought back were alarming. The parking garage had settled between 4 and 8 inches. The high-rise core had settled between 8 and 16 inches, with the central core documented at more than 14 inches of differential settlement. To put that in perspective, foundation engineers typically design for settlement measured in fractions of an inch. 14 inches is not a rounding error. It is a structural emergency. The building was not just sinking. It was sinking unevenly. The heavy tower was pulling away from the lighter parking structure, and the connection between them had turned into a structural fault line. Within weeks, the press had a nickname: the Leaning Tower of South Padre Island. The Texas Gulf Coast had its own version of Pisa, except this one was brand new, made of reinforced concrete and tearing itself apart in real time. If a brand new luxury tower sinking 14 inches into the ground before a single resident ever moved in sounds like the kind of story you want more of, hit subscribe right now. This channel digs into the engineering disasters most outlets bury after the first news cycle. Now back to the story, because what came next is the part that turned the construction emergency into a courtroom war. The structural damage at the tower garage connection was where things went from bad to irreparable. Ocean Tower's design had tied the massive concrete tower directly into the lower post-tension parking structure. They were physically connected, engineered as one integrated system. So when the tower settled dramatically more than the garage, enormous shear and bending forces accumulated at every connection point between the two structures. Columns cracked and spalled, with concrete breaking away from the reinforcement inside. Some columns required emergency shoring with temporary aluminum supports just to prevent further collapse. Those emergency fixes actually made the situation worse in one specific way. They altered how loads flowed through the already distressed structure. Standard engineering models rely on predictable load paths. Once you start propping things up with temporary supports inside a building that is actively shifting, those predictions go out the window. Engineers who inspected the damage compared it to what you would normally see after an earthquake. Except there had not been an earthquake. The building was simply too heavy for what was underneath it, and the ground was settling accordingly. The developers notified buyers that an expandable clay layer had compressed under the tower's weight, causing the differential settlement. That was a polite way of saying the foundation design had missed the single most critical factor in the entire project. The developers brought in forensic engineers from Walter P. Moore and Associates, one of the most respected structural engineering firms in the country, to perform a full evaluation. Their conclusions confirmed what the settlement data already showed. Compression of the deep clay layer had caused the differential settlement, which generated the shearing and structural damage visible throughout the tower and garage. Worse, the clay was still compressing. If the building stayed standing, the movement would continue. In July 2008, the developer filed a $125 million lawsuit against Rabba Kistner, structural engineer Datum Engineers, and initially the general contractor Zachary Construction. Zachary was later dismissed from the case, but the allegations against the engineering firms were pointed: negligence, flawed engineering, a geotechnical investigation that had stopped 20 feet short of the layer that mattered most. The lawsuit centered on a specific failure. Rabba Kistner had authorized pile depths of 95 feet based on borings that extended only slightly deeper, while the compressible clay sat between 120 and 190 feet below grade. The piles were bearing in sand above a geological hazard that their own investigation should have caught. Rabba Kistner publicly stood by their work. Datum Engineers either declined or could not be reached for comment. An appellate case eventually reached the 13th Court of Appeals in Texas, but the developer voluntarily dismissed the appeal, which in legal terms typically signals a settlement or a strategic retreat rather than a definitive verdict on fault. Nobody got a clear public finding of responsibility. The building was coming down either way. By late 2009, the owners made the decision: tear it down. The question was never whether to demolish Ocean Tower. The question was, how? This was not a typical teardown. The building had been engineered to survive Gulf Coast hurricanes. Core walls up to 30 inches thick were packed with rebar and constructed from reinforced concrete specifically designed to resist the kinds of forces you would normally use to bring a building down. Conventional mechanical demolition would have taken months and cost a fortune. Controlled Demolition Incorporated got the contract. CDY is the company that has handled some of the most famous demolitions in American history. The team described Ocean Tower as one of their most difficult implosions ever, ranking it second only to the Seattle Kingdom in overall difficulty. At the time of demolition, Ocean Tower weighed approximately 55,000 short tons, making it the largest reinforced concrete structure ever brought down with explosives. CDI would be breaking their own world record for the tallest reinforced concrete building they had ever imploded. The difficulty went well beyond size. The building was already compromised. Columns had been shored with temporary supports, which meant loads were not flowing through the structure in predictable patterns. The tower was leaning slightly north from all that differential settlement. The drop zone was tight, bordered by residential homes, Highway 100, and park facilities on nearly every side. CDY's demolition plan required precision that left almost zero room for error. The sequence was extraordinary. First, straighten the leaning tower, then tilt it approximately 15 degrees eastward toward the Gulf of Mexico. Then drop it vertically within a constrained footprint in approximately 12.5 seconds. Every calculation had to account for the fact that this was not a structurally sound building behaving in predictable ways. This was a compromised structure with damaged columns, altered load paths, and temporary shoring that nobody had ever tried to implode before. For the first time in CDI's history, the team pre-blasted openings into the tower's massive core walls using carefully calibrated charges. The cores were so thick and heavily reinforced that without weakening them ahead of the main event, there was no guarantee they would fracture during the implosion sequence. CDI also installed hundreds of meters of high-tensile steel cables throughout the structure to help control the building's rotation and guide the fall direction. CDI's president later noted that approximately 3.5 seconds of the delay sequence would determine whether this was a successful demolition or a catastrophic failure. 3.5 seconds between a controlled collapse and a 31-story tower toppling sideways into a residential neighborhood. The implosion went off as planned. The charges fired in sequence. The core walls fractured on cue. The cables guided the rotation. And 12.5 seconds later, $200 million of hurricane-hardened concrete dropped neatly into its own footprint. 3 years of construction undone in the time it takes to pour a cup of coffee. If this kind of story is what you come to this channel for, the failed projects, the courtroom wars, the dramatic engineering finales, hit subscribe so the next investigation lands in your feed automatically. We cover the biggest construction disasters in America every single week. Now back to the story, because the part most people miss is what Ocean Tower actually cost beyond the building itself. Nobody ever lived in Ocean Tower. 147 luxury condominiums, and not a single resident ever walked through the front door. Buyers who had placed deposits or signed contracts were left in legal limbo, holding canceled dreams of beachfront living and waiting years for any kind of resolution. Some had already been making financial plans around those units. Retirement plans, vacation plans, investment plans. All of it gone the moment the columns started cracking. The failure sent a chill through South Padre Island's real estate market. The entire pitch for high-rise coastal development had depended on buyer confidence that these structures could be built safely on a narrow strip of barrier island sand. Ocean Tower proved that confidence was only as reliable as the geotechnical work underneath it. And for a stretch of coastline that was actively trying to attract luxury development dollars, that lesson came at the worst possible time. The implosion itself became something of a media spectacle. Locals gathered to watch. News helicopters circled overhead. The video was replayed on every major American news network. It was later featured in engineering documentaries and educational content about foundation failures. The demolition that should never have been necessary became the most famous thing Ocean Tower ever produced. The building's legacy is not the lifestyle it promised. It is the 12.5 seconds it took to disappear. Within the professional engineering community, the project took on a second life as a case study. It is now cited in discussions about the importance of deep subsurface investigation, conservative foundation design on barrier islands, and the cascading failures that result when assumptions between the geotechnical team and the structural team are not perfectly aligned. One missed layer, one set of borings that stopped too soon, and everything above it paid the price. A $200 million luxury tower defeated by a layer of clay 20 feet deeper than anyone bothered to test for. 31 stories of reinforced hurricane-hardened concrete imploded into its own footprint in 12.5 seconds because nobody could afford to keep it standing. 147 luxury condominiums that never welcomed a single resident. 401 friction piles bearing in sand directly above the geological hazard that destroyed every dollar above them. A $125 million lawsuit that ended in a voluntary dismissal without a clean public finding of responsibility. A geotechnical firm that stood by its work. A structural engineering firm that declined to comment. A developer that lost everything. Buyers who lost their retirement plans. And a barrier island that learned the most expensive lesson in Gulf Coast real estate history. The Leaning Tower of South Padre Island is gone now. The concrete was hauled away years ago. The lot has been redeveloped. The story has mostly faded from the news. And somewhere right now, on another stretch of Barrier Island sand, another developer is signing the geotechnical contract on another luxury tower, asking whether the borings really need to go all the way to 200 feet. Because the same question that built Ocean Tower and then imploded it is the same question every coastal developer in America is asking every single day. How much soil do you actually have to test before the math you skipped costs you the entire building?